Hello and welcome everyone. I'm Martin Kletzander. I will be talking about features you might not know exist or might not know are helpful. A little bit of background info about me. I'm working here in Red Hat as a software engineer. I worked there slightly over 4 years now. I'm working on libvirt actually, and you might wonder why I'm doing presentation about compilers when I'm working on libvirt. And you might think that I'm not an expert, right? And to that say, you are right. I'm not. I'm just trying to convey some information. This is an area that's pretty interesting to me. And I would like to show you what the things are, what we can do with it, and maybe show you something that you will use and will help you in the future. So, let's start with the first question. I'm not sure if you're familiar with this code, if you've ever seen anything like that. Yeah, I forgot to tell you, if you have a good question or if you ask me something, there are 3 lovely scarves, DEFCON scarves. Feel free to ask. If you ask a good question, I'll give you one. You can come for one after the talk. So, first question from me is, what can you do with this code? What would you do if you stumble upon a hello world example for some language? What's the first thing you do?
Compiler.
Yeah, sure, compile. So, if you compile it, how much time will it take? 1 second, 2 seconds? How much time will it take if you need to tweak the compilation? If you need to do something on your own? You can't use the compiler. The compiler does not do something you want to do with this code. So you have to write part of it. If you don't know how to use the compilers that are available, you have to write your own. And that would take me months, maybe weeks for some of you. But what I want to show you here is that custom compilation of C code is pretty easy. I mean, not easy in a pretty specific way, but maybe easier than you might think. So, what to expect in this presentation? I'll be talking mainly about GCC and CLang. I'll show you what GCC plugins are, how they work, what you can do with them. There will be an example. Then I'll switch to CLang and LLVM, a little bit background info about that. And I'll show you various tools that are out there that you might not know as well. You should not expect some basic introduction about how to do GCC Hello C. I'm not going to be explaining that. And this is not going to be very language agnostic. I'm going to be mainly talking about, because it's CLang, so I'm mainly talking about C-like languages. And of course, you might expect some other things that are in technical presentations, right? Something will stop working because who knows how computers work. So, compiling. If you think compiling is binding of COM ports, this presentation is probably not for you, but feel free to stick around. Maybe you'll learn something new. So, to the point. Using the Hello World example, if you want to compile it to a binary, what are the phases the compiler will go through? Anyone? Yeah? You can generalize it a little bit.
Decompose the code until
Yeah?
sense tokens.
Yeah? I still generalized it a bit more. So first thing you do, because there's an include, and stuff like that. You pre-process it. After that, you parse whatever code is there. That's you're parsing the lexemes and you're doing syntax analyzation and so on. Then you get some language, then you get some abstract syntax tree or something, and you can do first passes of the optimization. Then you compile it, even though it's the same word as the compilation as a whole. It's being referred to as a compilation when you're when you're transforming the abstract syntax tree into assembly language. Yeah, sorry for that. Then you assemble it into machine code, and you link it. And of course, I did not mention a bunch of other stuff. You can do several passes of optimization and so on and so on. So, from a user's point of view, as we said, it's basically just running a command. You just run clang hello C, gcc -o, whatever. What if you want to change something? You want to change how the compiler behaves. You want to see what the abstract syntax tree looks like. You want to do some checks there. For some of the things, there are options. They are generic enough. For example, there's an option to stop after preprocessing. Anyone would know the argument for that? Great, good audience. I don't have that much scarves here. Yeah, cool. How about to stop after compilation so you can see the assembly code that was generated? Yes, -s. But the options are pretty limiting. What if you want to do something more? You might ask, what more should I do, right? Well, you can enforce some per project coding style. You do not do that in the compiler itself, because everyone who uses the compiler would have to obey your coding style. And there are some people out there who do not think your coding style is the perfect one, even though you know that, right? And what else? Type integrity. I'm going to show an example on that because it's harder to explain without code itself. There are some things you might eventually, or someone else, screw up, and it can crash on you, even though compiler did not see that there's a problem. I'm also mentioning custom code generation. Of course, the compiler generates code, a bunch of code, but I'm talking about custom code generation. For example, there's a thing that you can do. You can do function overloading in C, where you generate a different code based on what the function parameters are and so on. You can also do custom code generation. For example, if you have a structure and you want to have a function that does deep copy of that structure for every single structure there. That means deep copy means all the pointers reallocated and so on. And you cannot do that with some parameters. Also, code completion. I'm mentioning it partially because clang has a binary for that. You can run clang it's not complete. I'm not sure about the exact name, but you can run the clang binary with parameters and some code, and you tell it where you are, and it will spit out all the completion options. It's being used from text editors and so on. So the example for the type integrity, what I want to mention, is this. Let's see. Let's say we have some header file with a structure. Based on what you are compiling your project with, there might be some some how should I put it? Some part of the structure that is there if you're compiling with lib something, and it's not there if you're not compiling with it. Right? Then you have this file with the same file name, which is actually my functions, let's say. I just forgot to change that. And you have a function that does something on the structure. Also, based on whether you're linking with that library or not, you access that object that is or is not there. And then you have main, which includes those two files. And yet again, I have a problem with that. And it creates some structure, initializes to nothing, and then runs do something on that structure. Can you see a problem with that?
You have two files with the same name?
That's one problem. Yes. What I wanted to show you here is, if you look at my hands are shaking. Let's try this.
So where do you define this with lib something?
Yeah, it's usually defined in config H, right?
Alright. And
So
is that config H included in the left one?
it's not, and that's the problem.
Alright.
So for example, in here, the structure, the file that gets included, will have everything based on the config H.
Right, but the ordering is wrong, right?
If you include it here like this,
Then it will not work, right?
yeah. If you include it in here, and I forgot to switch those two lines, it's handwritten. Yeah, because I wanted to do the smallest example possible. If you switch those two lines, the first thing that gets included is my structure, and then the function. So if you create a structure, it will not have this pointer in there. So if you call the function on the structure do something, it does actually something. It's trying to access a member of that structure that's out of bounds of this structure. So you get a segfault, right?
Excuse me, I still don't understand. The file on the right top side, that's supposed to be a header file or a C file? This should be by so that's a
This should be a C file.
That's a C file.
Yeah.
What?
I wanted to do both header files and C files, and I forgot to.
Like, if it's a C file, then we would not be including the C file in main.c. If it's a header file, it would not be containing the
Yeah.
value of the function.
You're right. This should be a C file, and there should be part of it that there should be also a header file which includes config H, for example. So the point here is that you can have two files, and in each of those files you have the structure with the same name. You can pass a pointer to the structure, but they will, from both files, it will be visible as a different, as a structure with different sizes. Did I explain that correctly? Yeah. Sorry for that. I wanted to. A friend of mine told me that I should show you the type enforcement or the type integrity check, so I just tried to do it as fast as possible. Because it's imagine if I tried explaining this without the code, it would take much longer. You may say it's very rare. Yes, it is very rare. It should probably not happen. It is that kind of should not happen type of problem, and debugging this is probably not that easy. And GCC will fire a warning if you run it with FLTO. So if it does link time optimization, I'm not sure about the details, but it does checksums on some structures, and it will find out basically that it's not the same structure, and it's accessed from those two places. So, I mentioned GCC. A little bit of overview. GCC's new compiler collection. It has a bunch of tools in it. It can compile a lot of languages. And, for example, there's GCC, that's the whole package. G++ for C++ compilation. It can compile Go, Java, Ada code, and so on. And it also has a tool chain. Tool chain, those are basically the tools that the GCC runs in order to go through those phases I mentioned earlier. For example, CPP does the pre-processing, AS does the assembly, LD is the linker, AR archiver, and so on. You probably know that, right? You can turn on verbose compilation with -v, and GCC will show you each one of those tools that's being run with the parameters and a bunch of other info. So, compiler phases in GCC. Let's just go through that quickly. There are language-based passes there, which, as I said, it depends whether it's G++, GNU, Go, and so on. The language gets parsed into a abstract syntax tree, which is called generic, because it's not very generic because not every single code uses that directly. There are some what's in it there, but it's a generic tree, and it's the abstract syntax tree representation that you can work with. And there are some language-specific trees and other information that gets passed with the generic tree to other layers. But this is language dependent. When you have generic tree, you can run it, and whatever the language is on top of that, you can run it through the other passes, which one of them is called gimplification. That's basically transferring that generic tree into a tree address representation. Anyone knows why it's called Gimpel? Gimpel. I first thought it's generic implementation, but it's probably not. It's based on some earlier simple language that did not have goto and some other things. So I'm referring to that as a simple with goto. And of course there are other passes, 3 SSA, RTL, those are various optimization phases and so on. And then the assembly. We don't need that in the detail. Let's switch to CLang and LVM. So CLang for C-like languages is a binary that uses libclang. Also part of CLang are libformat and libtooling and other libraries that you might use. And some binaries like CLang format that does something like indent, if you know it a little more intelligently. CLang tidy, it can fix some stuff for you and so on. And that's basically, if you I might have it on the next slide. I'll wait with that. And then you have the LLVM, which is low-level virtual machine. That has its own tool chain. It also has its own language, which is not. I can't say it's even similar to Gimpel, but let's not go into details. You have a bunch of binaries that you can use for assembling, disassembling the bytecode, and it is all bytecode. You can compile into that bytecode, and you can interpret the bytecode. So it might be similar to Java for someone, but this is not used by default when you run clang file.c. The presenter stopped working. No, I don't know. Oh, okay. So, CLang does the, if you recall the previous slide for GCC and the phases. And here, CLang does that language-specific parsing. If you want to use LLVM, you should use -- emit LLVM. Otherwise, it will use the linker and assembly that's in the system, and you will get normal binary. With emit LLVM, you will emit then a LLVM language for your low-level virtual machine. The LLVM language is something that's used in the bytecode, and as I mentioned, it has the bytecode interpreter, so it can work like I'm hesitant to say like Java because I don't want you to throw oranges at me. So, quick recap. What did we learn? So we learned what GCC is. You probably knew that, right? Roughly how it works. The same for CLang and LLVM. What are similarities? There are similarities. Of course, you have to do similar things with the code if you want to have a similar output, right? But the similarity I'm referring to here is that there's a split between language-specific and language-agnostic part. And also what the differences are. Every part of it looks different and works different. So, what do those compilers expose that you can use to somehow use the power they have in themselves already, so you don't have to reinvent the wheel? GCC has a plugin API. You can write plugin for GCC and interact with what GCC does. CLang can do the same, way differently, believe me. Then there's libclang. As I said, CLang is the binary, and it comes with libclang. It uses libclang, but you can use it as well. The nice thing from them is that basically CLang is just small, relatively binary on top of libclang, and libclang does most of the hard work, and it's exposed to you, so you can use it. And there are other libraries like libtooling for reformatting and actually not reformatting, but refactoring the code, libformat for reformatting, and so on. So, really super short introduction to GCC plugins. GCC plugin is just a module that has plugin in it. GCC calls dlopen on it, calls the plugin in it, and you can then register callbacks for different events. Those events may be that something's happening, or it may just be a reaction to GCC asking you something. We'll get to that. And you use it like this. You just run GCC with fplugin, path to the plugin, and fplugin argument name equals value, and this creates an argument for you that you can use in the plugin. Of course, you can pass more of those. So, I'm not sure you will see this, but it will be in the presentation, and I can show you after if we get to demos. What I want to show here is that basically you include GCC plugin H. You need to define plugin is GPL compatible, otherwise it will not load. There has to be the symbol, but doesn't matter what it is and if you use it or not. It just checks if there's the symbol. There's the plugin init function. You get the arguments from the command line. You get some information about GCC version. And you can register callback to some events. I chose plugin finish just to say goodbye after the plugin finishes. There are a lot of things lot of things you get in those structures that you can use. And, well, we'll see. I don't think we need it now. So the plugin compilation is pretty straightforward. Minus shared is enough to create a shared library. This part here is to show GCC where to include the file from. So you run the GCC you want to use the plugin for, and if you use print file name plugin include, it will print the path to that include directory with all the header files. And then if you want to use it, as I said, you run it with fplugin. I chose to compile the same thing here just to see the difference, and the only difference is this parameter, and this is the output you will get, or I got when I tried it. So, little bit of info about to what we can react. There are the events, as I said. There's I use the plugin finish. There's plugin info event, which is, as I said, some not even that's happening, but GCC is asking you for information about your plugin, so it can output that information into verbose logs and everywhere else. And another event is plugin path manager setup, where you set up passes you want to react to. So don't mistake events for the passes we were going through. There are passes for that, and there are way too many other events that today is not enough time to cover all that. Then there are those passes for GIMP there's pass and even more others. That's all to be found in a documentation. Let's switch to CLang. CLang is, as I said, library used by libclang. Is library used by CLang itself. And what's a good thing is that it's public library. And another good thing is that it has a stable API. Apart from the CLang plugin API, you can write plugin, but it will not work in the future. libclang has a stable API. However, it has very sparse documentation. I read somewhere that the developers themselves see the source code as a documentation, and you get automatically generated oxygen, and that's it. There's one presentation from some LLVM conference where it's very nicely shown how we can parse something. That's it. But what's nice is that there are Python bindings. And what can you do with Python bindings? And for example, IPython, you can introspect the code. If you don't know what this function does, with IPython you put question mark there, and you get the doc string. And it's easier and faster than searching through the documentation. So I chose to show you an example in Python. What you need to do always after you import CLang C index is you create a new index, and that index is able to parse a file. You can give it parameters. It's you usually pass the parameters you get from command line, and then that creates a translation unit. The translation unit has something that's called cursor in it, and cursor basically I view it as a pointer to the abstract syntax tree, and you just call a function on that cursor. We just call a function on that cursor here, and that function basically takes the node the cursor points to, see if it's coming from file. If the file name is the same as here, then if it's not the same as here, we return because we only want to output information about the file, and then we see if it's structure declaration. for example. If it's structure declaration, we output the line and column and the name of the structure. That's it. And now we get and of course you have to traverse it through all the children because it's a tree. And this is few lines and you get, for example, all the structures. So this is just a quick example. Some interesting plugins I found over there. There's Egg Gcc Plugin, which is a plugin for GCC that will output LLVM code. So you can use LLVM bytecode using GCC. And that means you can use GCC as a front end for all the languages it can use. It can parse into LLVM. I don't think it's finished yet, but the plan is supporting all languages. There's GCC Python plugin, which I did not mention earlier for a reason. Since GCC switched from being written in C to C++, I'm not sure how it was used earlier, but now GCC Python plugin is quite hard to use. For me, I did not dive into details, but it's basically Python compiled as a plugin for GCC. You load that plugin. As an argument, you give it a path to your Python script, and it runs Python, executes that Python script, and from that Python script you can react to all those passes. What I forgot to mention with those passes, you can replace them also. Not only check what they are doing, but replace them with your code and generate something else. There's the XR sealing plugin from Mozilla, if I'm not mistaken, and it's basically for large codes, a code search and how should I put it, a navigation tool for example, for Firefox. Another plugin I wanted to mention, and I mentioned it, this GCC plugin in, I think, in examples or extras that will do that function overloading in C. So you're not using C++, you're using only C, but you have function overloading. So now we can get to demos. We've got still a few minutes, so I can show you some of the things we went through. So pretty quickly, because we have like 7 minutes, if I'm not right. Okay. So. Is this visible? And readable? So, I mentioned those clang format and clang tidy binaries. Let's start with those. I have some ugly code in here. As you can see, there are a few problems. It's the indentation isn't right. Of course, it's the easiest one. This initialization is basically deprecated since 1998. So there are a few small problems with it. If I copy that here and do clang format on it, it outputs quite nicely. You can specify so many parameters to that and change a lot of things. I just wanted to show you that it's easy to use. You can also call a tidy, which will not only tell you what the problems are, that there's an old style field designator for X and Y, but if you run it with fix, it will apply 2 of those suggested fixes, and that means that means it will fix it for you. There are a lot of fixits. If clang is able to provide a which is called fixit, and what's wrong, basically it looks like this. There's a problem, and this is a fixit for it. Then clang tidy can fix it for you. What else? I've got the script here that I showed. I don't see a left column here. I'm not sure whether you see it. But it's basically what we went through there. Let's use it on that ugly C file. One thing I did not mention, I'm not sure whether libclang Python bindings are available for Python 3. I only have them for Python 2. So if you cannot import it, be sure you have Python 2 run. And because, well, there was just one structure, you get this structure point is declared on line 6, column 8. If we were to change it to and delete this, you would see that it goes through. That was the skip for files other than Egg. You will see that it will output a lot of things. Everything that gets pre-processed and included gets output. To show the GCC plugin, well, as I said, this is how I compile it. I don't think I need to show you how the plugin looks like, right? It's the same thing. One thing to mention that I forgot to mention, this is how it works, but if you only use this and do not put path in there, only file name, it will not be able to load it because it is not in this path. This is a path where this will output a path where you need to install your plugins in order for GCC to be able to find it without a relative or absolute path. Well, we don't have much time left, so let's get this. Where did I put the? Yeah, here. Let's just really fast few demos because I want to show you the documentation links and tell you something else. So there's more info. You will get those slides posted on the DevCon website. The first is linked to GCC internals documentation. The second one is, as I said, the libclang doxygen automatically generated without any how to use it. I want to mention Eli Bendersky's website. I'm sorry if I'm pronouncing it incorrectly because I don't know him personally, but basically that guy posts a lot of very interesting information there, and so there's valuable information about libclang and other interesting stuff. And the last one is the link to GCC Python plugin and some information about me if you want to contact me. As I said, I'm not an expert in this. I just want more people to be interested in it, and I want to continue that work to create something usable. Quick recap. We learned how compilers can help us. What we can do now, we are able to write the GCC plugin. We know where to find the documentation, so we can do some stuff with the C code. We know how to use this libclang library and some other tools that you might implement as syntax checkers for your project or use for refactoring. You know where to find more info, and most importantly, you got the contact from me, and that's a reference to who not to blame if it doesn't work for you. because that's not my fault. So I want to take you back to that first code again. Woo! Misbehaves. Let's look at the code again. What can we do with it now? We can do the same thing. What we know, a bunch of other stuff we can do with it. We can change it in compile time. We can list information about it, and so on. And it will not take much time. We have the documentation, we know the tools, and so on. So what I wanted to leave you with is my first idea on the first slide, that custom compilation of C and C++ is easy. And that's it. Thank you. Should you have any questions, feel free to ask me. Yes? We'll probably discuss it here. Or if you have any other questions, feel free to catch me here or somewhere else during the conference. Thank you.
Pěkně. Vyčerpal jsi to do poslední minuty, ani ti nezbyl čas na dotazy.